All right, ladies and gentlemen, we're going to take a look at, like I said, solving systems of equations by graphing. So let's go through and fill in a little bit of our vocabulary. A system of equations is two equations in two variables. And that's what we're going to focus on. Is we're simply going to have two equations with two variables. So now we have x and y in the equation, which is why we're going to be able to graph all of these. We're going to graph these like we did our y equals mx plus b. In algebra 2, we do take a look at three equations in three variables, x, y, and z. All right? The solution to the system is found where the graphs of the two lines intersect. Because we're dealing with two variables, we're going to have both x and y, which falls on our coordinate plane. That's where we find both the x-axis and the y-axis. And so we're going to be looking at where those two lines intersect, which I don't want to talk too far from myself, which means the system has a solution that's going to be written as an ordered pair. Okay, guys? So what we're looking for is going to look a little bit different than when we just solved the equation. The equation just had x in it, or sometimes it just had x. Now, because our equations had x and y, we have to name an ordered pair. So you're going to look at where on the graph, where in the coordinate plane those intersect, and write me the ordered pair. And so what we want to remember, and I'm really kind of stingy here, ladies and gentlemen, with these, is that you can always check your systems. And we're going to see this a lot more second semester, whether you're still in my class or whether you move to Ms. Gillette's, is that you're going to be able to check your solutions by plugging the ordered pair into both equations and checking for a true statement. Because that's what we're looking for. We're trying to find the ordered pair that makes a true statement in both equations. Okay? So we'll take a look at what it means to check our answers, what it means to look for solutions as we go through here. All right, so here's what we want to do. You have what your first problems on today's assignment are going to look like. We're going to give you two graphs, and we want you to show me or tell me where they intersect and name that ordered pair. Well, the first thing I need to decide is, do these two lines intersect? Yes or no, Will? Do the two lines up there intersect? Yeah, they do. So now that we can find that point of intersection, I have to name that ordered pair. Remember, ordered pairs are named x, comma, y. So you've got to make sure you name the x coordinate first and then the y coordinate. So what's our solution to this, Lexi? Well, here's my ordered pair. Where does that hit the x-axis at? 1. So my x coordinate is 1. Where does it hit the y-axis at? 2. So my solution is 1, 2. All right? So it says determine what the solution is. Now it says prove it algebraically. That prove algebraic, ladies and gentlemen, is just a really fancy way of telling you to check. That's all they want you to do here is to check your solution. Well, how do I check my solution? Well, I've got two equations. I've got y equals x plus 1 and y equals 2x. What I need to do is plug 1 in for x, and I need to plug 2 in for y. So I have 2 equals 1 plus 1. When I simplify, I get 2 equals 2. Is that a true statement? Yeah. Remember what we said, ladies and gentlemen. We're looking for an ordered pair to make both equations true. So we got it to make the first equation true. I need to check it in the second equation. So I'm going to plug 2 in for y again. And I'm going to plug 1 in for x. 2 times 1 is 2. And I get 2 is equal to 2. Once again, that's a true statement, just like the first one we had. And so I can see that this ordered pair, even though I plug it into two different equations, gives me two true statements. And so that shows that that is the correct answer. Okay, guys? Any questions on that one? All right, let's take a look at what's next on here. Determine what the solution is, and then prove it algebraically. So I want you guys to try that one on your own at your seats real quickly there. All right, so Jack, what's my solution? Where do these two lines intersect?
3 negative.
Beautiful. This one, we can sit there and plug in negative 1 for y. And then you need to make sure, ladies and gentlemen, that you take the opposite of whatever your x value is when we have that notation. It doesn't need to have a negative x. It needs to take the opposite. And so because we had a positive 3, our opposite is going to be negative 3. But be careful with that, especially when you're plugging in negatives. This means to take the opposite of x. But negative 3 plus 2 is negative 1. So far, so good. We have negative 1 is equal to 2 times 3 minus 7. Negative 1 is equal to 6 minus 7, which is negative 1. So we get 2 true statements. So any questions on how to check your answers, ladies and gentlemen, or how to prove them algebraically? All right, I think that's questions 4 and 5 on your homework tonight. All right, so now we need to take a look at how do we solve a system by graphing. We need to graph both lines on the same coordinate plane, and so we have to figure out the best way to graph these two equations. If some of you think back to, I think it was around Thanksgiving time, or the end of the, not Thanksgiving time, I think it was the end of the first marking period, we talked about graphing using x and y intercepts, so that's one method. What method do we seem to use most often, though, in here? How do we graph equations like that? How do I graph those? Come on. Guys, what do we usually solve for? Y. We usually, what we're looking for to graph is y equals mx plus b. All right? So I'm going to have Will and towards the window. I want you guys to solve the first equation for y and kind of compare answers. I'm going to have Ms. Schaefer and towards the whiteboard to solve the second equation for y, and then we can compare answers. Compare real quickly with your seat partner or someone in front or behind you what answer you got for solving for y, so I can start calling on people. All right, Cameron, what did you get for your equation when you solved for y? I'm trying to do it real quickly in my head to make sure.
Y equals 7 minus 9.
We agree with that? Right-hand side of the room? All right, beautiful. The second equation, Jaya, what did you get for that? Right. We agree with that? Right, left-hand side of the room? All right, beautiful. What I need to do now is graph. So remember, the constant's my y-intercept, so I'm going to start up at positive 7. Stop and think, ladies and gentlemen, this is a negative x, which means my line needs to be going down to the right. So that means I need to go down 1, but I have to go over 1 to the right. I need to make sure that my line is decreasing. I have no clue right now where these two lines are going to intersect. So if you notice, guys, I'm making a lot of points. I'm not just going to put a couple points and then throw a line on there. I'm looking for accuracy. I need to know exactly where these lines intersect. So the first line that you graph, you really need to put nice, neat points or get yourself a ruler out. And make sure you have that line going all the way across your graph. Carefully connect those. That's one of my downfalls on the smartboard, is getting those nice and neat. But as long as you've got those points, ladies and gentlemen, even if your line gets off a little bit, we should still be able to find a good intersection point. This one needs to start at positive 3, that's my constant, and then I have a positive x, which means I go up 1 over 1. And now for the second one, I don't really need to graph a whole lot, because as soon as I graph that third point, I found where my two lines intersect. So we find this point of intersection. I need to name that ordered pair. It hits the x-axis at 2. It hits the y-axis at 5. So my solution is 2, 5. So really, Kenny? No, for the second one, you don't have to graph the whole line. I just need those two lines to intersect. But for this green one, I didn't know whether they were intersecting way down here. I didn't know if they were intersecting way up here. So for that first green line, I wanted to make sure I gave myself a lot of really good points that were quite accurate. So that's why I counted the slope out so many times. For my blue line, as soon as I intersected that green line, I knew what I needed. All you need is that point of intersection. And so I just went one more point to the right so that I could connect it and actually see the two lines intersecting. And then I stopped, and that was enough there. Okay? Ladies and gentlemen, let's turn to the back side. You guys have some on your own here. I'm going to have you actually has three types of solutions that we're looking at. You can have one solution, which is one point of intersection, which is everything that you guys looked at. We can have no solution, which means there's no point of intersection. And so that middle graph is the example of parallel lines. You then can have what is called infinitely many solutions. That's what we saw during the warm-up today when we said all real numbers. It was the exact same statement on both sides. And so we're going to have what we call infinitely many solutions, and that's what's on this handout, ladies and gentlemen, when they're the exact same line. So just like we could graph two lines that have the same slope, we can graph two lines that have the same slope and the same line intersect, which means they're graphed one right on top of the other. And so they're the same line. And so tonight while you're doing your assignment, you need to watch out for that. So that's why it's really important, guys, that you're solving for y carefully and that you know when you have two lines that have the same slope. So here you're looking for the same m value. Here you're looking for the same m and b values. Okay, guys? So that handout's just a nice thing to keep in there. Your assignment tonight, like I said, is the worksheet. So I'm going to hand that out to you guys.